All right, so in the previous lesson, we defined a test string methods class that inherits from the test case class inside of Python's built-in unit test module. Now, the reason we do this is to inherit a whole bunch of instance methods from the test class definition. And all of these inherited instance methods can be invoked within our instance methods, such as test split. And all of these inherited instance methods perform some kind of assertion. Again, an assertion is just a validation that an operation returns an expected value. So let's begin with the most common assertion, which is assertEqual. The assertEqual method, or the assertEqual assertion, accepts two arguments and it validates that those two arguments are equal. Behind the scenes, the method is actually using the familiar equality operator. So here's how it looks. Right here, I'm going to get rid of pass. Now we have self. Self is going to represent our object. Now remember, this object is going to have a whole bunch of instance methods, including the ones that it's inherited from test case. That's why we have to inherit from this, otherwise we would have no methods here to invoke. So this method is called assertEqual. Again, notice that assertEqual is not defined anywhere in this file, but it doesn't matter. We're getting it from test case. So if you were to go look at the Python code base and you were to go look into this module and the test class definition, you would find that it defines a assertEqual instance method, and that is what we're inheriting from. And that is why we're able to use this method within our test class. So this accepts two arguments, and this is what we want to compare. So as I mentioned here, when we're testing split, I just want to show you an example of what happens when we invoke the split method on a string. And as we know by now, the split method returns a list that represents the separation of a string based on a common delimiter. So for example, if I have a string like this, a-b-c, and I call the split method and I want to split by a dash, this should give me a list of the characters a, b, and c. So here, the very first argument that I'm giving to assertEqual is some kind of operation. This is what it's actually going to execute. And the second argument is going to be what I actually expect the result to be. So I'm going to put a comma, and here I'm going to put my expected result, and this is going to be a list of a, b, and c. So again, what Python is going to do is take these two arguments and compare them. So technically speaking, it doesn't matter which one you place first. The way I like to write it is to write whichever one represents my business logic. We're actually going to call the split method here. And then the second one is going to represent the actual expected result. So this is what Python is going to execute. It's going to check when I run split on this string with a delimiter of a dash, am I going to get back a list of A, B, and C? So when I execute this, we're going to get a completely normal output. So you're going to see here this little dot appear on my right-hand side and this presence of OK. So this dot represents a single test, and a dot indicates that that test was a success. A test is a success if all of its assertions are met. In other words, if Python doesn't run into any problems or any assertions that do not work out as expected. So let's do another example below. I'll create a line break. And here I'll once again take self, which is my object, and we're going to have the assertEqual method available on that object. So I'm going to invoke it. And let's do another example of split. Let's say I have a string here of D plus E plus F, and I want to split it by a plus sign. So the first argument is the operation that I'm going to ask Python to perform, and the second argument is the result that I want to compare that to. So I'm going to do a list here of D, E, F. And when I execute this, you're going to see on the right-hand side, it's still going to say ran one test, because this whole thing represents one test. This defined instance method is one test. So here, when we have number one, this is not the total number of assertions. This is the total number of methods that you've defined in your test class. So we have two assertions here, but one total test, and that's what it's telling you right here, as well as the total amount of time it took to execute the overall status. And again, each dot here represents a successful test. So if we have a dot here, that means that both of our assertions on lines 5 and 7 have passed. In other words, Python has confirmed that this equals this and that this equals this. Now, a common community convention and one that you should generally aspire to is to write one assertion per test. Now, this is not a technical requirement. It doesn't have to be strictly followed, but it tends to be good for organization, and it tends to make sure that your test is focused on one thing and one thing only. So for example, if I look at this, you can argue that the test on line number 7 isn't really necessary, because if our goal is to test that split is working, line number 7 is testing basically the exact same thing. Now, maybe you want that for a sense of security, but really each test should serve to isolate one specific bit of functionality and test that just that works. So you might argue that this is redundant, but again, it is in the experience of the programmer and what they personally believe to be the best case. And if it makes you feel safe safer to write 2 tests. I don't think that's a really big problem. I always say I prefer too many tests compared to not enough tests. So now let's take a look at how we would declare another instance method or another test within our class. Let's go ahead and delete this line right here. It's as simple as defining another instance method in the exact same class body. Once again, the same rules apply. You have to begin your function with the name test. That is how unit test looks for all of your instance methods that matter. So here I'm going to write test, and let's say I want to test another string method, since that is the focus of our class or the focus of our unit. We're focusing on testing string methods as we saw in our class name. Let's test the count function on a string. So once again, I'm going to call this test count, and here I'm going to pass in self. That is required for every instance method. And once again, we're going to have access on self, on our object, to a whole bunch of assertions or a whole bunch of instance methods. In fact, if I do self and I do .assert here, you're going to see a whole bunch of different methods that we've inherited. And we're going to be diving into all of them throughout this section of the course. Once again, we're looking for assertEqual here. This just asserts that the arguments are equal. So for example, if I want to test something like count, let's say I'm going to have a word like beautiful, and I want to count how many times a letter like U occurs within it. So in beautiful, the letter U occurs twice, so I can feed this in as my first argument, and my expected result is going to be 2. I expect that when Python calls the count method on beautiful with an argument of U, I should get 2 right here, and I'm asserting that those 2 arguments are going to be equal. So I'm going to re-execute this file from inside Visual Studio Code, and now you'll notice we're going to see ran 2 tests, because remember, each test is each one of our instance methods. And then at the very top here, we're going to have 2 dots, which indicates 2 successful passing tests, which means all of our assertions or all of our invocations of assertEqual have proven to be correct. We are getting the expected result. All right, so now that we've seen what it looks like when a test passes, let's take a look at what the terminal is going to look like when a test fails. So what I'm going to do here is replace my U here with a letter Z. Beautiful obviously doesn't have the letter Z occurring twice, so our assertEqual is not going to be a success because Python is not going to get an expected result of 2. It's going to get 0. So it's going to compare 0 and 2 and say that's not equal. So you'll notice the output here is going to be a little bit different. We're going to get a trace error. And as we scroll down, you're actually going to see we're going to see a assertion error, right? We're going to see 0 is not equal to 2. And it's going to say we ran 2 tests and failed. We had 1 failure, which means 1 test failed. If we scroll up here, you're also going to notice here, in addition to our dot, which represents our successful test, that's our test split on line number 4, we're going to have this letter F, and that F is short for failure. So for every single failing test, you're going to have 1 letter F, and for every single passing test, you're going to have a dot. So a dot is good. At the end of the day, you want a completely green or passing test suite, so you should see a whole bunch of dots. So as we scroll down, again, it's going to tell us what went wrong with this specific test. You're going to see it written out here, and Python is saying assertion error 0 is not equal to 2. I got 0, but you gave me 2. So you might be looking at this output on the right-hand side and thinking to yourself, okay, I see an assertion error. Doesn't that mean that the assert keyword is being used somewhere in the test case class definition within the unit test module? And the answer is you're absolutely correct. Somewhere behind the scenes, these developers who built unit test as well as the test case class are using assert to validate that these 2 values are equal. So you might be asking to yourself, why do I want to use these inherited instance methods, these validations and assertions like assertEqual, instead of just using the built-in assert keyword? Well, remember, the assert statement would cause our program to crash in case the assertion isn't met. Unit test, in comparison, allows the test runner to continue running and checking other tests even if one of them fails. So in our current example, test split is working, but test count is not. Well, let's imagine the test split is going to break. So let's say instead of F here, I'm going to say G. G obviously doesn't exist in our string, so we're going to get a list of D, E, F and compare that to a list of D, E, G, which is not equal. But now notice if we had assert written, we would have the entire program crash. However, with unit tests, they take care of that exception handling and all of its complexities for us, which means that even if it experiences an error right here in the assertion, it's going to proceed to running all of the other tests in your test suite. So if you have 100 tests and 100 of them fail, the unit test will still test all 100 of them, right? Which is really great because the developers have taken care of all of that annoyance of assertion and all of its failures right here. The goal here is to get to failure because failure tells us there's something wrong with our code. But imagine if we had to test one test at a time and wouldn't be able to test anything else until we fixed it one test at a time. What this allows us to do is to continue running this program and testing all of our tests, even if one of them fails. So that's what the instance methods allow us to do, and that's why they are preferred over assert. And here on the right-hand side, you're going to see here for every single failure, both in the test split and test count, we're going to get this output. We're going to get right here, assertion error 0 is not equal to 2. That's coming from this line number 9 right here. And if I scroll further down, we're going to see an assertion error here. These lists differ. This list is not equal to this list. In fact, Python is going to be super helpful and it's going to even tell you, hey, this is what I got, and this is what you gave me, and you can see F is not equal to G. It's going to show you with a caret exactly where these things are not lining up. So it's trying to be as helpful as it can to tell you what's not going right. And here up top, instead of having any dots, we have 2 Fs. That means 2 failing tests. Again, a test is not equal to an assertion. It's equal to an instance method that must begin with the name of test. All right, and that's all there's to cover in this lesson. We introduced our very first assertion, which is called assertEqual. All of the assertions that we're going to be invoking here are going to be inherited from the test case base class, which is why all of our test classes have to inherit from that base class that is available from within the unit test module. We simply define an instance method that begins with the word test. We make sure to give it self, and then within the body, we use self representing our test object, and we invoke those assertions or those validations or those instance methods that we get from test case. In this case, with assertEqual, we give it 2 arguments, and what Python is going to do, or what test case is going to do, is compare that those 2 arguments are equal. And it's going to raise a failure in case it's not met. And it's going to continue running all of the other tests in our file, in our program, and many times in our entire code base. So one test failure does not deter the rest of the suite running. That's why we want to use all of these built-in testing tools, because they're designed to be optimal and automated. All right, so there's a lot more to cover, and if the syntax is a little bit confusing, don't worry, because we're going to get a lot of practice with using the self keyword as well as invoking all of these inherited methods as we explore all of the other assertions that we get for free from test case. So there's a lot more to cover, and I will see you in the next lesson.